Today we're going to be working on solving equations by using addition or subtraction. First thing we need to talk about with this lesson is the difference between an equation and an expression. An equation is saying something like 3x plus 2 equals 4, and an expression is something like just 3x plus 2. So the difference here is that an equation has something that it's equal to. It has some value that you're setting it congruent to. An expression is something that you can just simplify down to its simplest form, and then once you're done, you just circle it there. So the difference is that there's this equal sign, and the way you can remember that is by the word equation. It's got that E-Q-U-A, very, very close to equal. So equation has an equal sign, expressions do not. So our goal for today is to solve equations, so solve expressions that have something that's equal to, by getting a variable by itself. And we're going to do that by using properties of numbers. So an example of something that we're going to be able to do is something like x plus 2 equals 14. Our goal is to get that variable by itself by using properties of numbers. So before we get into how we're going to do that, I'm going to do a quick example here using balance. So here is a balance. On the left side you've got 9 blue circles. On the right side you have 6 blue circles and a maroon box. The question up in the middle there is, what is one of those maroon boxes equal to? How many circles is that equal to? Well, basically our goal, if it's an equal sign, is to maintain a balance. That's why it's on this balance. So how do we keep these two sides of the balances equal? How do we keep it the same? Well, if I were to take one of these blue dots and take it off, then I must have to do the same thing to the other side. That will keep its balance. So if you keep doing this, but take off all 6 of these circles, then you have to take off 6 circles from the other side. When that's done, you see that you've got 1 maroon box on one side and 3 circles on the other side, and we have a balanced equation because we took off the same amount of circles on each side. So as long as you're doing stuff equally on both sides of your balance, or equal sign, then it's going to maintain its value. So the answer to this problem is to the question, how much is 1 maroon box equal to? You can say 1 maroon box is equal to 3 blue circles. We have one more example like this. Very easy. Doing the same type of logic. If I were to get one of these maroon boxes by itself, I would just take off 1 blue circle from each side. That will maintain its balance, making sure the balance isn't uneven. Therefore, 1 maroon box is equal to 2 blue circles. Now if we were to go back and look at this problem from before I moved it, we have a total of 9 blue circles on the left side, and we had 6 blue circles on the right side. My question was, how much is one of these boxes? That is our unknown value. We represent unknowns with variables. I like to use x. So if I were to do this as an expression, I would say x plus 6. That would be that total amount on the right side. And on the left side, we just have 9. This fulcrum in the middle can be represented as an equal sign. Because these are balanced right now, we can say these must be the same. So now we have this equation, x plus 6 equals 9. Well, using our properties of numbers and properties of equality, if I were to get rid of 6 on the right side, then I must get rid of 6 on the other side, thus leaving me mathematically with 3, and leaving me on the right side with an x, and that gives me the exact same type of solution. These two things match up. 1 maroon, 1 x, 3 blue circles, the number 3. So our goal is to do something called the inverse property. If you look at example 1 here, you've got x minus 3 equals 11. Our goal is to get rid of that negative 3. How do you get rid of a negative 3? Well, getting rid of a number is essentially getting it to 0. Our goal is to get any addition or subtraction equation like this, get that number value to 0. Well, if you think of a number line, we've got negative 3. How do you get negative 3 to 0? Well, you must have to add 3 to get it there. So, if I were to add 3 to this side, then my balance would be uneven because I've added or I've gotten rid of that 3. So in order to keep this balanced, I must add 3 to the other side, giving me 0. So this goes away. It simplifies to 0. X plus 0 is just 0. Or sorry, x plus 0 is just x. Equals x, or 11 plus 3 is 14. And there's my solution. X must be 14. You can go back and check and plug it back in. What is 14 minus 3? It should be equivalent to 11, and it is 11 equals 11. So we know we found the correct value of x. Example number 2, very similar. I have a positive 2. Again, with the number line, if I'm at positive 2, how do I get this value over to 0? I must have to subtract 2. So if I subtract 2 from this side, I'm changing that left side's value, making my balance uneven. So I must have to do it to the other side as well to make sure my balance is the same. If you do one thing to one side, do the exact same thing to the other side, no matter what. This reduces to 0. F plus 0 is just f. 21 minus 2 is 19. So your variable f is equal to 19. And that is addition and subtraction solving. I've got a couple more examples that are a little more complex. Let's get into those right now. Example 13 here. If I have x minus a negative 5 equals 12, your goal is to get rid of this value of negative 5. How do you get rid of a negative 5? Well, you must have to add 5, right? Well, that would be your first instinct. However, if you add 5 to this, you get x minus 0 equals, you must have to add 5 here, equals 17. Well, let's go back and check that. 17 minus a negative 5. Well, using our leave add change, this becomes 22. And you note that these are not equal. So what did we do wrong? If we go back to the very beginning, we have minus minus. In other words, leave the front, change this to addition, and change this from negative to positive, giving us x plus 5. So instead of adding 5 in this case, we should have subtracted 5. So be very careful. There are examples that will try to trick you. So please, let's rewrite that so it looks better. So please make sure if you can change anything to addition, please do. Another example of that could be something like this. You've got y plus a negative 2. Notice this is already in addition, so just look at the number you're trying to change. We're trying to get rid of a negative 2, so in this case you would want to add 2 to both sides. Now these are pretty rare cases. Most of the time they won't be written like this. However, they are still out there, and I'd like you to be aware of what you can do to tackle them. So in the case with number 13, you'd like to change. Like if you look at it, you see the negative, so you think, oh, I must have to add. Well, take a second, change to addition, and see what logically you have to do. Number 14, notice it's already in addition, so just look at the value of negative 2. How do you get rid of a negative 2? How do you get that negative 2 to a 0? Alright, there is solving equations by using addition or subtraction. Good luck.